This looks really complicated, but in fact, it's just the same ideas that we've broken down in these. It is a step up, so I'm going to naturally assume that you already know what a true length is, and also have to divide a circle up, and some basic understanding of drawing straight away. If not, just circle straight back to my previous videos, which are these, and then just come straight back to this one. And if we do know how to make these, this one's a good step up from this one to the next stage. So let's break down this breeches piece and make it simple. I've marked the model out. The basic information that we know the diameter, so I've drawn that down. We know the top diameter, so I've drawn that on. We know the height, so I've drawn that on also. And that gives us the first true lengths, really. These are true lengths. We can measure these accurately on the model and in true life. So I've put all these true lengths on, ready for us to go. Drawn the plan view. Looking on the plan view, as we can see. And I've also divided the circles up, well, this side into 12, and the base circle into 12 there also. Both sides are symmetrical, so I don't need to develop both sides. So I'm going to concentrate on this side, and I've highlighted that in grey to show we're just doing this particular side on this one side. So with all this basic information on there, I'm going to simply start by joining this point to the end one. This links both the big and the small circle together, and then we're just filling these lines in from 12 to 5, and so on and so forth down there. Draw the lines in, and they'll give us as triangulation points to help develop the development. Now I'm going to do the same on the bottom. I'm going to join 0 to 7, 1 to 8, 2 to 9, etc., etc. Drawing these lines back, this gives us the correct angle we need, but I only need down this point here. This is our joint line. We can now point this point here and finish the top look of our development. Now from here, we can then show us joint line running down. And that shows us true half of our development. So with joint line in, we know that this point here is where it intersects. So we need to put these on these points here, which will be this point here and this point here. It intersects there also. And these are relevant. So that now gives us all the information we need to start development. Starting point, I'm going to start with this true length up here. This is going to be the middle of our development. It's a logical starting point because it's a true length, so it makes an easy point to start the development from. So just mark the line in. This will be our centre line. Mark the centre line on there. 7 at the bottom and 0 at the top. Now to pick the points we need to start the development from. Back at the plan, we just need this point from 0 to 8, and then from 7 to 8 to create this first triangle. I'll start working the true length out from 0 to 8, 0 to 8, which is the same on both sides because it's symmetrical. We'll pop that onto development. We could take this spacing now, which is a true length in itself, and step it off on number 7 to where it intersects. Step the distance off, step the distance off. 2 points marked in place now, number 8. So now we need to work his way back up the development. And the next one, which will be number 1 in the series. So we need to measure from there 8 to number 1 on his plan, from number 8 to number 1. Plot that on his table, and that'll give us his next true length. Same as before, but in reverse. So from number 8, markers line up. Number 8, markers line up. Now find the spacing at the top development, which is quite simple. As the bottom, we use this spacing here. Doesn't matter because they're all the same spacing. Once we've got that, take it over to his development. Mark from 0 onto both arcs, and that now creates our number 1s. And now it's a simple repetition of that process all the way around, all the way through to number 10 at the bottom. So I'll start working my way around now and get all these points in to the next stage where we need to stop and change what we're thinking. So we've got this development going around here. This is this bit here. And this bit is this little bit here. So we hit this point, but now we just found these points here. Now these points are on here, so we'll call that A, we'll call that B, we'll call that C. We'll only to use these 3 points, as I said before, it's symmetrical, so we found these points. And as usual, we've got to use this true lengths, plan length against vertical height. But on these instances, it's a little bit different. So that is our vertical height for A. That is our vertical height for B. And this is our vertical height for C. So we need to project these across to our table. Mark that one A, this one B, this one C. Now, for the next part of the development, A to 3, which will take that dimension there. Now, we don't plot it on the normal bottom, we'll plot it on A, because that is our vertical height. So we'll step it across on A, like so, at a true length. We'll mark it onto our 3 side. With that marked, we now need to get the true length of A. So, as usual, we will take the dimension of A, like this, so we can mark that on there. But the vertical height will only go to A because that is the vertical height we need. And this will give us a true length, our first point. Step that on 10, arc it across, and that will give us point A. Then from point A to 4, we'll mark that on the same parallel, on the same true length as A. Take the true length, stick it on A, strike an arc. So it's the same spacing at the top, because it's obviously circumferential length. That marks off point 4, point 4. The next point to find is 4 to B. 4 to B. This time, that true length, vertical height, sorry, is on B. We need to mark it on B. Take its true length and mark it on 4. Strike an arc back towards A. Now to find the true length between A and B. So we take the distance of A and B, plot that on A, like so, and then from A, the vertical height only goes to B, so we only need to plot it to B. Then from there, it's simply A to B, A to B. Now with point B found, we just need to take point B to 6, find the true length of this one. We plot this on B, because it's starting from B. The true length is at the top, so that'll be his vertical height on that plane there. So B across there, from B onto his vertical height, and from there, a simple arc up, Those marks in place, again, back to his spacings at the top diameter. Strike an arc. But last point to find, C to 5, and this will give us the top of this. So we'll go on to C, mark that off, set that dimension from there, like that. Mark on 5, mark an arc, We just need this last point, which is B to C as a true length. C to B, going to be on C to B line, so we'll put it on the B and the C line, so we take that point from there to there. Easy as that. Put that on B, and that will get the C mark. With the C's marked in place, the last and final one, this is its own true length anyway, so we can take that straight off there. Take that size, C to 6, C to 6, C 6. We'll take his last spacing off. Check that off on 5 to the arc, 5 to the arc. And this will give us as last and final point, point 6. All the points are marked now on for the development. Just need to line them all up. I'm going to use my FlexiCurve. So I'll whip through that now, and that will give us a full final shape of what the development's going to look like. And there it is, all finished and completed. So if you followed all the way through, congratulations. You've just completed one of the classic sheet metal developments, a Breeches piece. This is one of those pieces which is, the knowledge is passed down from fabricator to fabricator, and hopefully a few more to come. And remember, every complex development always starts with a simple line. Until next time.